You remember in one of our other videos where we were trying to figure out how different sized molecules interacted with each other. One of the molecules we used was water and the other was alcohol, and we found out that the two, when they're equal amounts, do not actually add up to double of what you have. But what would you say if we could go back and we could deconstruct a molecule, in this case water? As you remember, water is an oxygen molecule, or an oxygen atom, with two hydrogen atoms. But what if we could take that and we could split it back into its individual oxygen and hydrogen atoms? Well, we have an experiment where we can do that. And it requires us to have a beaker. In this case, it's a 500 milliliter beaker. It requires us to have some Epsom salts. I've got some distilled water from my local store, and I have a 9-volt battery. So what I'm going to do is I'm going to take and fill this up to about 450 milliliters of distilled water. I'm going to take approximately 7.5 grams or 7.5 milliliters or a half a tablespoon of Epsom salts. In this case, it's magnesium sulfate. I'm going to pour this in here, give it a good stir. We want to make sure that we have these ions all distributed through the liquid. The object of the exercise here is the 9-volt battery has two poles. It has a positive and a negative pole. And for some interesting reason, because of the way the electricity runs back and forth between the two poles, we can take water and we can create oxygen and hydrogen gas back into its original two atomic forms. So I have this stirred up. I've got the magnesium sulfate dissolved in solution into the water. I'm going to take my 9-volt battery, going to stick my 9-volt battery in. Let me turn that around so we can see a little better. There goes the 9-volt battery, and as you can see right away, I am getting bubbles off of the 9-volt battery. There we go. Wow. And as you can see, I've got about twice as many bubbles coming off of one side as I have coming off of the other. So that would mean, if I've done this correctly, that I'm getting hydrogen off of one side and oxygen off of the other. So let's zoom in there a little bit. Let me turn you where you can see it a little bit better. Now, I want to capture this gas. So how do I do that? Well, I'm going to use a couple of test tubes. And I have these small test tubes here. And what I have to do is I have to fill them with water. Now, the trick is you have to put these in with the water in the tube. So I have to put this under the water, take my finger away, and stick it over the pole. There we go. Because I want to capture that gas. Let's go ahead and let that. Let's see if I can move that out into the middle of that beaker a little bit better. And it doesn't want to cooperate, but let's go ahead and do that. There we go. Okay. So now I'm capturing oxygen on that side. I'm going to get my other test tube, which I have right here in my hand, and come over. And what we're trying to do is we don't want any gas in that test tube. No gas whatsoever. So I'm going to stick this in the water, put my finger over it, stick it in the water, take my finger off and stick it over the other pole, which I've done. Now the object is, can he maneuver this around so that we can see? Yes, he can. I'm going to go ahead and stick the fork in there to hold those up. And now what we're going to do is we're going to measure the bubbles on the top. Let me roll that in there. There we go. Aha! There's the bubbles on the top. And as you can see, on the one side, we're getting it much faster than we are on the other. So if we were to do this in an atomic structure, it's H2, so there's twice as many hydrogens as there are oxygens. So we can make the assumption that on the left-hand side, we are creating hydrogen gas, and on the right-hand side, we are creating oxygen, because we are creating it twice as fast as we are on the other side. So let's go back up here and take a look at the top again. So as you can see, that bubble is forming on the left about twice as fast as the bubble is forming on the right. So let's go ahead and see if we can focus on that for a few minutes. I'm going to turn this around so that you can see it. Pull that back just a little, and we're just going to do a little time lapse in real time and let you see this happen. And while it's doing that, I'm going to back this off a little more. Let me get my handy dandy background in there for you so it can see it a little better. But as you can see, on the left we are creating hydrogen gas. On the right we are creating oxygen. And we are creating that hydrogen gas about twice as fast as we are creating the oxygen. Let me see. Nope, that fork is not having any effect on anything. I thought maybe the stainless steel would have an effect, and it is not. Now, how does this work? Well, the 9-volt battery with the poles on top, the poles are just close enough that the electricity is riding the ions in the salt and jumping from one pole to the other and completing a circuit. What we are doing, this is poor man's electrolysis right here. We are separating the water into its constituent components. And you'll notice that if we back this out just a little bit, you'll notice that in the hydrogen one, we're getting some kind of solids forming. Well, those solids are the sulfur out of the magnesium sulfate, the salt that we put in. So we're not only separating the water into hydrogen and oxygen, we're separating the sulfur back out of the salts, which is dissolved in the water, and that's where that yellowish color, and that's where those floaties are coming from on the hydrogen side. Now I'm going to go put a couple of things away. You just keep watching it. Let me know if anything happens. I'll be right back. Checking in with you. Wow, that's working really well. That is a brand new battery. We just bought it at our neighborhood Walmart store. And wow, we are getting a lot of sulfur out of there. And as you can see, we are creating the hydrogen. Actually, it looks even more than twice as fast as the oxygen. Our oxygen bubble just isn't quite forming as fast as we thought, but we are definitely getting much more hydrogen than we are oxygen. And look at that sulfur growing in that test tube. Isn't that amazing? And we're going to check this here in a minute to see if it actually is hydrogen. I think I have a plan on how we can accomplish that. But you just keep watching that. We're going to let it go for another, 3 or 4 minutes, and then we'll see what happens. And we're back. Let's see what we're doing here. We are sure creating a lot of hydrogen. Not quite as much oxygen as you would think. We're going to let that go another minute or two. But as you can see inside the test tube there, we're getting yellow building up. That yellow, come on, don't fall on me now. That yellow is sulfur. I'm sure there's some magnesium solids in there also. And we're getting some other stuff from the battery on the bottom of the container. But we are sure doing a great job here. And I notice that we have bubbles. There we go. There's some more of our oxygen. Up. We lost it down there. That's what happens when you start playing with stuff. I can pick that up and set that back on top. There we go. There we go. Here's what I want to do is I want to try and collect as much hydrogen as possible, because what I'm going to do is take a match, and when we pull that off, I'm going to have a lit match right next to it, and we're going to see if we've actually created hydrogen gas, because it should go poof on us. And I see some black stuff floating in there now. I wonder if we're creating some magnesium at the same time. And then in our oxygen one, we are still creating oxygen. We have bubbles down at the bottom of the test tube. I don't know if you can, yeah, there you go. There's one that just went up. So what's happening is we have oxygen molecules, or oxygen atoms, that are clinging to the glass, and they're not coming up as fast as the hydrogen one is. That hydrogen is forming very, very quickly. We did this in the classroom last year, and if you've got your worksheet in front of you, you can go ahead and continue to fill it out. But the question was, can we deconstruct a molecule? And I believe we can. And in the process, we have proven that there are more hydrogens than oxygens, because we have much more hydrogen gas than we do oxygen. We've separated the sulfur back out of the magnesium sulfate, the salt that we put in there, the Epsom salts. And we know it's not the water because we're using distilled water. Distilled means that we've boiled it, collected the steam, recondensed it, and we've got all the minerals out of the water. So the water is not a factor here. What we're seeing is come out of what we've added in. When we smell this, we're going to smell a distinct sulfur smell. So we've proven quite a few things in this laboratory, and all it's required is some water, some Epsom salt, and a 9-volt battery that we can get at the store. And as we can see, we are still creating that hydrogen gas quite quickly. All right, let me go get my matches. Here we go. Up. Don't scare me like that. I didn't know what was happening. Now the backdrop is falling. I have to come back and redo this one. All right, so I'm going to light a match. There's our lit match. Let me reach over here. We want to hold that as close as we can. Nope. But we still have sulfur solids inside. Definite smell of sulfur, that rotten egg smell. We've turned our water yellow in the beaker. See how yellow that's turned? We've introduced the sulfurs back into it. We have oxygen. Let's see if we have a little oxygen here. Oh, we'd have to let that go overnight. Our fork that we used, which is made out of stainless steel, we have not done anything to the stainless steel. It's still good. So that was not a factor in our experiment, other than we cleaned it really well. And then we have the oxygen. So there we go. All right, hope you enjoyed it.